Hello. I'm now immediately closing my connection to the server for remote desktop. Okay, this might be a super sketchy stream. Turns out I ran out of cellular data. Somehow I was using 9 gigs a day on the 4-hour days. I have no idea how. So this is sponge Wi-Fi, and I don't know how this is gonna work. This has never, ever worked. So we may bail out of the stream. I don't know. So, I reduced the bit rate to 500 kilobits per second for this stream, hoping that that might fly under whatever the cutoff is. I don't know. So, yeah. We'll see how this goes. Anyway, yeah, I got 2 more of these things, and now I'm trying to figure out where they're going to go. So that's fun. I have no idea. I initially thought that, you know, on this back wall, maybe I'd move like the cleaning supplies from along there. It would take up the whole thing all the way across. So yeah, I got no clue. But I'm going to have all the places in the world to organize the things now. Still insane. They only give you 50 gig for unlimited data. Yeah, it's pretty bad. What are the boxes? These are parts organizer drawers. And I'm going to be organizing all of my capacitors and stuff into it. I'll tell you what, okay? If the stream starts to fall apart, like really, really badly, here's what we'll do. We will switch to a parts organizing stream, because that will be really low bit rate, or won't look bad, really low bit rate. So, yeah. Okay. We're gonna not do the stream subject first because there's this thing here. And this thing is a USB foot pedal.
Web subbed as Bryman says. End of line.
One moment. I don't have the ability to see that up here right now because, frankly, I didn't even know that the stream is going to work. I'm surprised we're making any kind of progress right now. I'm kind of staying on OBS, which is all right. Let me know when we're back. Are we back? Is it back? Okay, we're back. Okay, we're back. Alrighty. I reduced it from 500 to 400. That's not a game that's going to be very fun to play. So, okay. Yeah, anyway, foot pedal. So, you guys know that the chat there is done using totally custom commands and stuff. And I got the GPIB monitoring things going on. Well, I wanted to add, yeah, DZAC, we hit the cap. We are on sponge Wi-Fi right now. Yay. Looks exactly the same in 360p. Well, that's good. Looks normal on mobile. Man, maybe I've just been wasting bandwidth, you know, having like high bitrate streams. You're going to pedal power the stream. Well, so here's the thing. Last stream, I said, hey, you know what would be really cool? Okay. I have the edit mark redeem. And when I'm recording for a video, what that's supposed to do is put out a sound that goes into a separate recording channel that I can then look at in the editing software and see like, oh, there was a beep there. That meant something important happened. So I thought it would be cool as if not just you guys were able to trigger that with a channel point redeem, as if I'd just be able to, boop, hit it with a foot pedal and have that happen in the background. So I had that thought, like I should really integrate that. And then once the foot pedal idea was there, I was like, you know what else would make sense? Is if the foot pedal could be held and then I could operate the front panels on the GPIB equipment without like having it time out and kick me out of whatever menus and stuff. So I actually spent a bunch of time yesterday while I couldn't stream implementing it. It should work. So what I need to do is I need to stop the existing code, pull my changes, make a couple of tweaks to the code, and then we should have foot pedal support. So here's what I'm going to do. I'm going to plug this into the monitor because it's got USB ports because it's a weird monitor. There we go. So that'll get USB pedal going here. And then let's get crazy and we're going to try to make this work. So the first thing I'm going to do is I'm going to stop the stream, the office side code. So we're going to kill this. All right. Gone. So that's not going to affect chat. All that's going to affect is deck talk right now. So, and hello, Digital Ice Age. One of the things I'm doing right now will directly benefit you. All right, get pull. Yeah, sure, whatever. Permission denied. Oh, no. What? That's super annoying. Okay. New plan. Let's go here. Get pull https://github.com/stream dash integration. It's not, you know what? I wish pull would act as a synonym for clone when you're not in a repo. Clone. I can't believe I spelled integration correctly on the first try, or I've misspelled it every time. All right. Now I need this file and this. Okay. So I'm going to open this and this because we need to merge a couple of things here. So there are three new modules here. We need out sound. Actually, we don't want out sound, but we need out JSON. And then we need the foot pedal here. All right. Then we need to end or connect to the foot pedal. That code will go here. All right. So this whole setup is very, very weird. OBS didn't die in the background, right? It did not. Okay, good. Trying to be aware of that. Stream foot pedal. Oh yeah, I need these. So I need all of this out deck talk. And we're back. You know, I wonder if I could set OBS to like automatically try to reconnect. Oh, wait, because I'm doing SRT recording. I don't know. If I just have to keep hitting restart every now and then. I mean, that's not like the worst thing. Okay, so we got, no, I need a foot pedal. 1, 2 here. Okay, foot pedal. Now, foot pedal needs to go to those, but it won't go to out test, actually. We don't need that. Okay. Boom. All right. Get rid of that. Time to get dial up, yeah. Oh, I might be able to reduce the audio bit right now that I think about it. Okay. Is that going to be it? No. I need foot pedal disconnect. All right. Boom. Why are none of these run? Oh, because they aren't actually run local. Alrighty. Let's see if that works. So stream remote. No input hid. Oh, yeah. Sudo apt. This is going to be kind of a pain in the butt. Python 3 hid. Okay. Okay, fair enough. Install Python 3 hid. Yes. Huh. It's a good thing I got lots of data, huh? That's because, you know, I got to install things. Why not? Deck talk? All I have to do is just this. Okay, out sound is not defined. Why is it not defined? Okay. Back to here. No module named play sound. Play sound. Ruh-roh. All right, so this is where this gets fun, because now we break things. Sudo pip 3 install play sound, and it's like, no, you're gonna make me sad, don't do it. And I'm like, I don't care, just be sad. All right,
TikTok is now online. End of line.
hid raw px failed open thingamajig. Oh man, am I not in the plug dev group? Groups. No, I'm in plug dev. LS USB. We got PI engineering, foot pedal. Okay, it's there. Why?
TikTok is now online. End of line.
Was error open fail? Okay, well, let's just try that. Sudo su, and then stream remote.
TikTok is now online.
That works. Okay, now if I...
As Prime says. End of line.
Okay, got it. Yeah, all right. Now this should make a sound. But it didn't. Okay. Well, let's try another thing here. I'm like, have we broken it yet? Potentially. I don't know. It didn't play that sound when it should have. So that's cool. Okay, I'm gonna run the GPIB software backend. That. And I'm gonna run the GPIB controller thing here, but first I need to do a git pull. Oh yeah, Ben, we were out of cell data, so you know this is chomp data. Okay, stream GPIB. Okay, so here's what I'm gonna do. All right, we got that going. So let's turn on the DMM. Okay, is it showing up? I think I need to refresh this cache. There it is. Okay, fake device. You know what? That's not quite what I wanted, but I'll take it. All right, so that's constantly updating. If I hold the foot pedal, does it stop? Yes! Release? Look at that! There we go. So one thing worked. Okay, that's fine. That's better. Okay. That's what I want. So now what I is the P stream GPIB to full GPIB dot py. We got more. What do you mean F? It's still going. What are you talking about? It's trying to stay up. Okay. Audio stuttered. Is it? Okay, is it acceptable right now? I need more information because I can't watch my own stream. Why? Well, thank you for the 100 bits. Okay. Local GPIB here. Okay, so I changed the GPIB code so that I can just do boop, no, boop, boop, and bam, that's it. Now they're all good. One line for everything. Run this. Okay. And now that'll update. Okay, we're still showing fake device. Why are we showing fake device? Fake device shouldn't be. Oh, I know why we're showing fake device. That's on me. Local GPIB. And now, bottom 34, 30 something 78. I don't know. It's the thing. Browser. No. Refresh cache. Am I in big picture mode? What? Whoa, what happened here? Oh, I gotta turn the 34401A on when I start the code, because if it can't, it's badly written code. Okay, so in a moment, actually, if I refresh this, refresh, okay, now, there we are. Okay, so here we go. Foot pedal stops updating, release, goes back to updating. So, why is that so handy? Because now I can change the update interval for the modules, and I will do that later when it's not as big of a pain in the butt to do things. But long story short now, let's say I'm configuring a power supply here. GPIB pause, also make an edit mark. No, so the foot pedal, don't look at that part. That's in progress. The foot pedal has 3 buttons. So middle, sound, right, hold is pause GPIB. So I have to hold it. So that's how that works. So this is edit sound. That is pause GPIB reading. Give me one moment so I don't explode the bit rate here. Let's see. Sounds like the audio went down the wrong pipe. Pipe audio, pipe routing. I don't remember. That should help a lot. Yes, yeah. Digital Ice Age. There is something I haven't had a chance to look into, but apparently in Fairlight somewhere, there is a feature called transient detection that'll leave marks of some kind. The audio track for the edit mark sound is a completely separate silent audio track except for those. So it may be possible to just have it put markers where the beeps are. I'm really hoping that that's the case because that would be super awesome. So left pedal restart SRT stream. Yeah. So I almost added OBS WebSocket support. I was this close, and then I realized I couldn't think of a single reason I needed it. So, but that would be one. Anyway, so if I'm doing VSET, number, blah, blah, blah here, and then I wait, eventually the input menu here will, if I talk for long enough, close on its own like that. Whoa, crazy. But now if I hold the foot pedal, I can stay on this menu indefinitely because it will never try to query this while I'm doing the foot pedal. And I can reach everything here while I'm doing foot pedal stuff, and that won't be an issue. And I get the same benefit on the 34401A over here. So I can turn off the power supply. Over on the 34401A, you can see it's blinking constantly. Every single one of those blinks is a refresh on the foot pedal. Stay solid now. It's so nice. That's going to be a ridiculously helpful feature. So, yeah. Digitalized like a tone detector or something. I'm not exactly sure. I think it's meant to look for like pops, but we're going to try and abuse it to not look for pops, but just beeps. So, but yeah. Okay, I think that's going to be that for now. So, okay, let's go over what exactly we're actually able to do today. So I have a couple of objectives here. Complains the pedal is the wrong place when you move around. So that's why it's in the corner, because it's as close as it can be to the correct place for all use cases. Okay. I have two objectives for today. One has to do with this. This is a realistic MC1201. So I believe that this is a, let me pop the grill off of here. Yes, tweeter and woofer / mid driver speaker. There's nothing wrong with this, so don't worry. But, oh, that's super annoying. I didn't realize that. Drat. So what I wanted to do today was look at the crossover on here so that we could like measure what the crossover frequency is between these, because we could do that with the spectrum analyzer. I'm now realizing the only way you can get into it is by removing the speakers. So that kind of sucks. Maybe we'll still continue. You know what? We'll see how bad that is. But I think it would be really cool to use the spectrum analyzer in the scalar network analyzer mode and use it to measure the crossover points to the speakers, because I think that's possible. I mean, it's 4 screws, but do you know what the inside of these are like? It should be full of batting, and it looks like the crossover is attached to the back, and I don't know if it's going to be able to come out. Yeah. So other speakers that I've worked on this, the panel where you connect the speaker cables on the back pops out. This is inset. So it may be possible that we remove the speaker and then there's screws on the inside and then I could pull it out through the front, but I don't know. Anyway, so yes, I would like to do this. Now, we are better equipped today than the last time we did this. It's a vector network analyzer. No, it does not. It only has scalar. So, I have 50 ohm terminators. So we can actually do this correctly now rather than with the ghetto terminator. So, just plug it in, turn the volume right up so it shakes itself open, yeah. And then I get evicted. Scalar Bode plot measurement. All right. Then, why does the manual call it network analyzing? That's my only issue. Is like, I feel like this is the earliest possible network analyzer, that it's what it started out from, and then there is contemporary ones that work differently. But I think this is where it started out. Marketing lies. I don't think it's marketing lies, because I don't think there was anything that could do phase and amplitude at this time. But I don't know. Measure the return wave. I mean, isn't that the point of the tracking gen into? Can do S21 as itself, but S11 and S22 external. Okay, that information is lost on me, Wizard Tim. All right. Ghetto Terminator, I mean RoboCop. Anyway, yeah, let's, I'm gonna get my Ghetto Terminator out of here, because we don't need that anymore. Oh, I forgot it's also... Ugh. This was stupid. So many dumb things. All right. Oh, I can turn off the tools here. All right. You know, I'll leave this in there for now. Okay. S21 is the gain from port 1 to port 2. All right, I don't know. Okay, the cable. Well, I'm trying to figure out how we want to do this. Let me do a little bit of cleanup here. I was working on something here earlier, and I was kind of trying to find all the caps. So turns out we did recap the 1600, and then when I went to power it, something bad happened to it. So that's unfortunate. I want to check one thing on here. Wow, the audio level on OBS is way higher than the what you call it thing. ATEM, that's it. Anyway. Okay. All right. So yeah, I messed with a bunch of stuff here. Okay. And got things in the way. Just meh. That. Okay. Now we're gonna have some space for working on the speaker over here. So, he's multitasking, yeah. Recap the what? I dropped out? The Toshiba T1600 laptop. The big, chunky, Fisher-Price looking laptop. It didn't work. After I powered it for the first time, it died, apparently, even more. So, and we have not returned to it or even opened it to see what exactly went wrong. So. All right. Oh, I forgot about that adapter. BNC to RCA. Okay. Okay. You know what? Let's just start taking this thing apart over here so that we can see what we got, where the audio is better. The only first time it's not even more is true. Oh, you know what? I just realized this is still on cheater Zoom. Okay. Kurt 1443, thank you so much for the Prime sub and for 31 months. My apologies for the utterly infuriating audio issue. Just why? Why? That wasn't a internet dropout. That was OBS just died for some reason. Dropout. I have no idea why. Wet, thank you for the tier 1 sub there and for... So, I've complained about this before. Hold on. One moment. So, I'm going to go back like a bunch here. Okay. I want you to look at this. Okay? Here was David's sub from a couple of days ago. Resubscribe for 34 months. They've been subscribed for 35 months. Okay, so I assume that is a 34-month streak, and their total number of months is 35 months, okay? So I would call out 35 months. That would be the number. Wet, I don't know how you managed to do this. Yours is 12 months, a streak, but 9 months total. I have no idea what is going on there. Huh. It might be buying subs in advance. I don't know. That's your little secret. Okay. Prepaid for 12 months or at the 9th month. Okay, well, that could be it then. All right. All right, well, the 9 months? All right. I want to try a thing. Okay.
Elite Carl subbed as tier 3 and says get the air chopper deck talk. Have a good weekend, everyone. End of line.
Alien Carl, thank you for the tier 3 sub. Holy moly. Thank you so much. And for 35 months. I really appreciate that. Thank you so much. All right. I am going to get started opening this thing. No sudden loud sounds. You'll scare the encoder. Well, actually, I was originally trying to make a sudden loud sound, and I'll reveal why later. All right. So I'm going to remove the cables, so that way I don't have to, like, rough them up as I flip this thing around. It looks like it should be a little brighter. All right. Let's chuck that down there for now. Okay. So, someone put the speaker goo on this thing, and I don't get why. So, this is wet, and it's sticky. Dude, it's just a small Radio Shack bookshelf speaker. You didn't need to do that. The speaker itself is probably worth less than what you did. So for those of you who may not know, I think it's called... Is it called Speaker Dope? I'm not 100% sure. I've never used it before. So it's like a... I'm not 100% sure because it's going towards Audio Fool, but it's potentially legit. It's for making sure that the cone... oh my gosh, my brain is completely blanking on this. I have not... I am... rubber coating? It's not a rubber coating, no. No, that's not the surround. Oh my gosh, what is this thing called? Dope, that's right, I use dope for building model airplanes. No, this is the cone. This is... I am blanking entirely. Diaphragm, you call it the surround? Okay, so the surround, I guess. It's... If you have a fabric surround, okay, then you can add this stuff to it to try and keep it malleable so it can move without being damaged. So if you have a rubber surround, you would not add this stuff, but you do add it to a fabric surround. And it's even a thing to coat your speakers in it and then leave it. And then like a decade later, you'll notice that the stuff will have like worked its way down to the bottom. So you flip the speaker around, the driver, fancy terms, and then you let it go the other direction. So again, I don't know why someone would have put it on this particular speaker or driver, because that's a real unnecessary step for something like this. Okay. So irritating. Schmide, though, thank you for the tier 1 sub and for 25 months. I really appreciate that. I don't appreciate the horrendous audio issue. Okay. It's not a problem with the deck talk. Okay, so this actually has connectors on it. That's sweet. So, yeah, I'm going to take a picture of which way they're on there so I don't screw up the phase on the speakers. If you've never experienced two really big speakers out of phase, first off, I'm happy for you. Second off, if you have, you may have had the experience I've had where it can physically hurt. It is not a fun experience. If you got the big enough speakers right next to each other. Well, right plus, they're not marked plus and minus. That's not how it works on that, something like this. Oh, it is plus. It's barely way down in there. Huh. I've never seen that. Because it's AC, it doesn't actually matter. Okay, so here's the batting that I was talking about. So this stuff's in the way there. And there is our crossover. Is it a single capacitor? There's not even a resistor? That's weird. And we're back. Okay. I could take this. I can't take this out. There's two screws on it. Let me see if there are terminals on this. So then we can take out the whole thing. These are wood screws. The other ones are actually machine screws, and then there's inset nuts on the back. So weird. Connectors! Again, wow. This one is marked with a red thing on there, I guess. Huh. Alright. Maybe I'm wrong. It's been a little while since I've opened speakers. Like, literally the last time I did was on video. So you can go back and look up my Technics speakers. Alright, and the terminals are different sizes, so you'd have to try real hard to screw them up. Okay. Now we can notice that the crossover is glued in. I mean, that's actually a really good idea, but getting it out just got a whole lot harder. Huh. All right. Well, we're going to try this. We'll just try measuring this. How about that? Because there is no... Oh, there it is. I found the resistor. It's a potentiometer. Oh, this is actually really cool. We can control what audio goes to the tweeter with this potentiometer. That's the resistor part. So we can actually change what the crossover frequency is. Okay, this could actually be really cool. All right. So this is going to be our input. This will be our output. I could input to the back, but these are directly attached to the input because there is no crossover for the woofer. Okay. Huh. This is cool. This is going to be interesting, actually. All right, let me find a thing or two here. So I think I should use these. Because I can just clip these on, although I don't know what impedance these are. Actually, they shouldn't be any. Okay, so I have that. All right, and then I think I have another one of those somewhere around here with the oscilloscope stuff I bought, but I don't know where it'll be. You know what? We don't need that because our programmer had recommended that I buy, not those, not those, these. Boom. BNC to RCA adapters. So for the other side, we'll just use these. And then the only downside is that I need a gender changer because apparently I was an idiot and didn't think to get the other gender. But that's fine. I guess I could also just use a cable. Actually, I kind of want to try that. Yeah. Let's actually use some of my BNC cables. I'm going to run 2 longer cables over to here, and then we'll do that instead of dragging the speaker over to there. This is probably the inadvisable. Important question, what ohmage are the speakers? So the tweeter is 8, and the woofer is 8. But we're not driving the speakers. So we're just going through the, which will be a high pass. Okay, well, let me know when I'm back. Back? Okay. Again, that was OBS crashing. That was weird. It's never crashed. Anyway, why do I need to build 80 ohm termination? I'm confused. We're not going through the speakers. We're only going through the resistor and capacitor that are in the audio filter. Need to build 8 ohm terminator. The speaker is designed by that, but we're not. The speakers aren't going to be in the circuit. They're fully removed. Filter is designed to have a load. OBS update or something. I don't know. Maybe it's OBS is dying. Just, I don't know. Need to simulate the tweeter for the filter to work properly. Huh. Okay.
As tier 1 and says end of line.
Well, that. Okay, should I just run the speaker then? should I just plug in the speaker? I don't think there's a reason not to. Nesreal, thank you for the tier 1 sub and for 31 months. I really appreciate that. May as well. Yeah, I mean, you can just keep the speakers installed. You could do that. All right, then we're going to do that. It's just going to be the tweeter, so it won't really matter that much. All right, so I'll just leave the tweeter installed then. Do I now measure? Yeah, so I measure at the tweeter. All right, I'm swapping what's connected where because these cables are really chunky and I don't want to drag the tweeter down anywhere weird. Problem with the real speakers, the noise it makes during the test. I mean, I don't mind. Do you guys mind? Might be interesting. Fiction at 3, 2, 1. I mean, we could just adjust the amplitude on the output. I'll start it at 0. We'll see how it goes. Okay, so cable 1. I think it'll be cooler to hear it sweep, but SIGGEN power may be too low to hear it. That's kind of my guess, but I don't know. We'll find out. I'm going to move the camera over to the spectrum analyzer view here. Although, you know what? Actually, let's take full advantage of my extended cable range. What did I just unplug? HDMI. Okay. I'll fix that in a moment. Why is this like not working? One moment. I'm going to put the camera on the other side of me. If I can. Oh, I see what's happening here. One moment. Yeah. Okay, so there's that. I'm going to try an HDMI cable that might be bad. So let's find out. Ow! The air compressor has sharp bits. Okay, do we have video? Cool. Okay, that helps. Now, this needs to run up this way. Push this slightly farther back. Okay. This should give you a black screen. Okay. This cable goes to the input side, which goes to the tracking gen. I think I'm at a point now where I can probably start leaving these little caps off. I think I'm using this thing enough at the moment. So that goes in there. All right. Hold on. Stop frequency 22 kilohertz. That way it doesn't kill the speaker with like megahertz stuff. Okay. Then we have, I'm going to decouple this. I'm going to put on one of our fancy new 50 ohm terminators. There we are. Make sure we're on that input. And I am going to have to grab, there's supposed to be a thing right here. Where did I put it? There it is. You even start below 0 hertz? Yes. I can do that by moving the center frequency like this, but it doesn't like it. There we go. Store has 50 ohm terms. A store has 50 ohm terms in stock. Amazon, and barely took them forever to get here. All right. So this is going to be the input, and I'm connecting to the output now. All right. Why is that doing nothing? I'm going to turn up the amplitude. Well, that doesn't make sense. Why is it not doing anything? I'm going to put this on its side so that I can control the pot. Well, that's weird. I mean, I see a minor, like, adjustment. So marker, if I put this here, offset, go over to there, there is a 2 dB, 1.8 dB difference. That's weird. I think it depends on what encoding device uses. Was a crossover? This is a high pass filter, so the bottom should be cut off. I don't know why it's not. Change the decibel for division. So it's auto ranging. Yeah, out of range. Is that over the full audio range? I expect the knee frequency to be pretty low. It might be all squished up to the left side. It is over the full audio range, yes. I mean, stop frequency at 10 kilohertz. You don't want 50 ohm terminator connected for this. You want the high Z. Okay. Then I will remove the 50 ohm terminator. That's what I was thinking, but I didn't want to mess with it. But so to clarify, because we're using this output, well, it's still. So I should be good removing the 50 ohm terminator, right? Tweeter is a terminator, but that's only 8 ohms. Yes? Okay. Okay, well this now really sucks. Hold on. Preset, stop, 22K. Okay. I hear nothing. 8 ohms is the expected impedance. Yeah. I'll set start to 50 because it better not be there, but it's still gonna. I don't know. It's weird. Need to lower the RBW. Check. SIGGEN is connected to speaker terminals. High Z input is connected across the speaker. Yes. RBW. So, quick sanity check here. If I just... There's no reason... I mean, here, I'll just do it with the 50 ohm terminator. Just going to run the tracking gen straight in. And then turn it on. That's with a 50 ohm terminator. But I maybe... I think I should remove this. That doesn't seem right. Oh. Okay. That's correct, although I don't like the drop-off, but maybe that's because I have this on there. There we go. Kinda. I don't know. That's weird. Okay. Now, stop. 2 kilohertz, 100 hertz. Res here. Okay, leave it at a 4.4 second. Okay, I'm going to disconnect. This is output. Okay, so should I just make an 8 ohm load then if the speaker requires too much power to do this? Because it does seem like that. I mean, I can do the same offset measurement here. Let me go back to marker. So if I go here and then here, we can see that there is a 2 dB difference, roughly. Speaker or resistor still 8 ohm. Resistor need just much power. Okay. So what you're saying is we need to build my amplifier with a tip 120. Okay. I really wish I had a DC block. Just test a random cap you have lying around, make sure that cap isn't cooked. So, how would I measure the capacitor? Would I essentially connect the input and the output to the 2 legs of the cap, and then have the 50 ohm terminator on the input? Very low power, no problem. So this is my first time doing this. This is why I'm not really sure. Put the capacitor in series with the signal. Connect grounds. How? There's only 2 pins. Wait, you're saying you connect... So the shells of... Connect the outer shells direct across, positive to the positive side of the cap, negative to the other side, go to the center terminals. Is that what you're saying? It would be a DC block, but DC blocks are also a high pass filter. Yes, the DC block and some low. Okay. I don't need the 50 ohm terminator because we're just using the internal tracking input. I'm going to turn this down. All right. Grabbing a random cap. I know there's some loose ones here. There we go. This is a 470 UF cap. Okay, tracking gen is this. Output is pick a range. There. Okay. 111 this fast? Okay. Yeah, Atom Fighter, that's pretty easily doable in Audacity. This is like the fancy pants nerd way. Is that correct? That seems so weird. For giggles, I'm going to try a different value. You have an LCR meter? The capacitor and the speaker is still good? I mean, yes, I definitely have. Yeah, the LCR meter is just right here. It's just right here. It's just... It's right over... It's located directly in front of my face. Impedance is mismatched, so it's all wonky. Impedance is mismatched. Oh, you're saying it would need to be plugged... Oh, should I plug in the 50 ohm terminator? Is that what you're saying? use the 50 ohm input? I could, but I'm going to be a big baby and wait until I have the DC block. It looks perfect for that cap. Okay. Now, let me try a 100 UF. Good decision? Yeah. Okay, I may have made that cranky. Well, it looks so weird now. You know what? Whatever. Okay. All right, that's 100. Why does it look exactly the same? That's weird. Okay, so the crossover cap is supposed to be 2.2 microfarads. I'm powering up the LCR meter. This is, of course, a bipolar cap. For all I know, I should have mentioned that, and then everyone would go like, "Oh yeah, that's it." Resonance frequency similar for most through-hole caps. Oh, that's a resonance frequency. Ooh. So, do I need to get like farther down to see like an actual filtering happening or something? 2.2 UF on the cap. It's flawless. Reactance effect. Oh gosh, I hate RF. Okay. The reason I'm not a ham and don't plan to be a ham. Okay. How about I just plug the capacitor direct across from the speaker? So that is not going to help. There is a capacitor in the speaker. You got that analyzer? You opened the RF can of worms? No, I got a low frequency spectrum analyzer. Don't put the RF voodoo on me. I'm saying RF2. Big order every reaction between the winding. Yeah, that does make sense. There is no speaker here though. This is just the capacitor. Also, I got a 10 dB attenuator for this because I don't know. I'm trying to have all the things that I could possibly want. Man, that sucker is heavy. Why? Can must be like way overbuilt. Okay, so let me ask this. If I were to use the SIGGEN with a higher output power level than I assume this does through this, as on the high impedance input, could I potentially get something out of the crossover? Something about the frequency, about the length of the cabling, power lines model like RF. Well, I do have really long, stupid cables here. Maybe I should just bring the cap or the speaker over closer, because I was trying the long cables as a test. Yes, you can do that, but you need to use max hold. Okay. Yeah, because we're going to be... Yeah, that makes sense. It's a good idea to leave that attenuator on the sensor of input all the time. Only remove it when you're absolutely sure you won't fry the input. First time I want power. Well, I was going to do it on the 1 meg input. I'm just apprehensive about literally everything. All right, let's try this a little less stupid then. Okay, so I'm going to disconnect everything here. Okay. So first, I'm going to just bring everything over closer. And we're going to repeat the last test, but with as short a cabling as I could possibly do. Okay, so I am reconnecting the tweeter again here. Bringing this over. Attenuator needs needs a 50 ohm termination work. It's one part of a voltage divider. Okay. And the synced. So I'm not sure what you mean. I don't have the external oscillators connected on these. I could, but I don't think I'm going to need to do that. It's not going to match the tracking gen sweep, if that's what you're thinking. But like our programmer mentioned, as long as I use the max hold, we'll see the maximum peaks of the sweep as it goes by. Okay, so... Well, I know I have more of these, and it's driving me nuts that I don't know where they are. But I can work on, use something different here. So... Wait, what's this? Oh, that's perfect. Yeah, let's use those. Ah, stupid safety jacks. Wait, do these BNC doodads do the safety jacks? They do, nerds. Okay. No, they don't. All right, time to cut off the safety jacks one more time. Do, 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 do. Whee! Okay, so I'm going to connect these clips, which are just banana, directly to the BNC adapter, and then I can connect that into the input. Okay. Whoops, I just stepped all over the foot pedal. Okay. That was an unfortunate pause. Let me double check a thing here. Okay, Portizo, I just saw your message in Discord about the thing. All right. So I'm going to connect this for right now, just as a reminder. This is my input. Turning that down. Stop frequency 22 kilohertz. Start is still 0. Okay, input goes into the speaker. Oh! I actually hear it this time. Yeah, it does sound like a guinea pig. Stay hydrated, you're right. Okay. Why didn't it work? Weird. Okay. So that. Then I need the female to female coupler, which there's probably one in play, but oh, it's on the cable down here, isn't it? Okay, it really does sound like a guinea pig. That's hilarious. Is this how Moog started? Yeah. Bad cable. That would be really annoying since they're all brand new. Ah! Okay, it's sucking at this again. Okay, so stop frequency 10 kilohertz. Oh my gosh! Okay, this is too much fun. I am very much liking this now. Don't worry about the overload. There. Can we even overload using the tracking gen? Like, actually damage it? Because I feel like the answer is no. Oh, I really like this. Okay, so marker, the knee is about only 600 hertz? Really? That seem right? Seems a little low. Oh, wait, I got the pot. I can tune it. Hold on. Wait a minute here. I want to make this faster and garbagey. Okay. I am messing with the pot. It is doing literally nothing. Oh, well that's cool. It's not a pot. It's it's an RCA input with a plastic cover on it. It's knurled and everything. It looks. Back. Oh, whoops. Oh man, that's hilarious. Okay. Well, now I'm happy. Now I'm happy. Okay. I need a more complicated speaker. I need a 3-driver so we can see way more interesting crossover. But this works. Okay. Oh man. I'm digging the speaker chirps too. Might be possible for your SA to control your SIGGEN over GPIB. Ooh, I don't know. I mean, well, actually, yes, it could. I don't know how easily. So, the SA can have the keys all remapped to send HPIB commands, GPIB, whatever. But I don't think it can like just output raw data. There is, and I'm not kidding, nearly 2 decades between these two pieces of hardware. So I don't know. Oh, this is cool. Stupid calibration. You can disable the calibration. I forget how you do it. It's something like save off and then 5, I think. Ooh, you know, that's interesting. Super fancy analog synth. So it doesn't start actually responding to audio until about 1500 hertz. Maybe here, maybe 1000 hertz. So I feel like this crossover could be slightly better designed. Or maybe you want it to be flat at where the frequency response actually is. Oh, is that so, or can we just not hear it? It's a lower frequency, so we would be able to hear it. I am enjoying this so much. Okay, I want to test all my cables now. They just wanted to block the really low stuff. Yeah, 1000 might make sense if it's a mid-range and a tweeter. I mean, it kind of is. This tweeter definitely says tweeter on it. I mean, it's real tiny. This is the driver for the tweeter. It is not a substantial sized cone. I'm sorry about that, Moonwire. But Moonwire, thank you so much for the tier 1 sub and for 32 months. I really appreciate that. Feel realistic item could have been better designed. Response that is duh. Yeah. Tweeter's bigger than those 2-inch RC subwoofers. I mean, I guess, yeah. Okay. I am extremely satisfied now. So let's disconnect the speaker. We accomplished what I wanted to here. We didn't need to bring the SIGGEN and higher power into this either, so that's nice. So what I'm going to do now, I'm going to remove this, and then we're going to plug all of the cables I used in. Well, actually, we're just going to plug one of the 6-foot cables in and make sure that they're not bad. So yeah, that's why we have filter speakers, still absorbs power even if it can't produce sound, and that's how you fry it. Yeah, that kind of thing. So you can get distortion in the drivers if you have them trying to work at the frequencies they're not designed for. That's why I'm saying it's not good at reproducing sound below 1000 hertz, so the cutoff frequency should be somewhere around there. Ideally, actually, this is kind of a whiteboard, like, thinking. On the whiteboard, what do you guys think of the whiteboard move? Because I'm thinking I could put the parts organizers in a 4 or 2 of it right there, and then no more whiteboard. And I kind of wouldn't mind that, since leaning over the table to draw on the whiteboard kind of sucks. But I don't know where it'd go, because it might have to be like right here on this wall, and that's not super convenient either. Anyway, I would draw on the whiteboard, but I can't get to it right now because there's a camera in the way. Dumb question. What's the line on the meter telling me? That's not a dumb question at all, actually. I guess I didn't explain this even in the slightest here. Let me explain this to everyone who doesn't who doesn't know what's going on. My apologies. I should have thought of that. Camera. Okay. So what's happening here is the spectrum analyzer is outputting a signal here that matches a point on this line. So you can see a little dot moving. It's outputting the matching frequency that it's measuring right there. So it's outputting the frequency and then reading it in over here. That is going through the speaker and then coming back, and it's going through the filter for the speaker. The filter is lowering the audio after or below a certain frequency. The reason you do this is that the speaker itself will have a usable range. So in this case, I was saying the range seems to be 1000 hertz and above is where the speaker is good. You really don't want sound below the ideal range for the speaker to be going into it. So the whole purpose of a multi-driver speaker crossover, okay, that's the part inside of the speaker that has capacitors, is to only allow the frequencies of audio that the individual drivers in the speaker can handle, to only allow those frequencies to go to those speakers. So in this case, we have a single capacitor in here that is used to lower or attenuate the volume of the frequencies below what the tweeter can handle going to just the tweeter. If we measured the bigger driver here that was in this speaker, it gets sent everything. Ideally, we should actually have the opposite kind of slope going to the bigger driver, where the slope would taper off after a certain frequency because the bigger driver won't be as good as those, or at those compared to the tweeter. So what this is, this plot is a measurement of where the frequency drops off as it goes into the tweeter. That is all this does. I'm curious because I haven't messed with this. I think, I didn't do, why? Reference level track doesn't do quite what I thought it would. Maybe reference level is what I want to mess with. Okay, never mind. I regret touching any of that. But anyway, that's what we're measuring. Bigger driver is a natural low-pass filter. You know, it was somewhat, yeah. So, let's see. So yeah, amplitude over frequencies, yes. So you can think of it as the maximum amplitude. So, okay. Yeah, let's check my cable now. So I'm gonna go ahead and remove everything. Pull the speaker aside here. And what, in reality, it's probably one of my janky, like, homemade banana jack cables that was the problem. All right, so I'm just gonna plug this in here and in here, and then preset 1 meg. That cable sucks. What? Wait, why? Why is that cable terrible? Is it because it's so long? That's a 6-foot BNC cable. Is the SA driving the speaker right now? Oh, my apologies, our programmer, if you missed it. Yes, it was driving the speaker when I was showing the curve. Right now, it's not. Right now, it's driving just a 6-foot BNC cable that is apparently garbage. Bad quality? Huh. Okay. Here's a foot. That one BNC cable used 50 ohms on the high Oopsie, we're back, maybe. Okay. That's 6-foot cable with terminator. Isn't that that pretty awful? Dude! Come on! Ben, thank you for the 100 bits. Yes, looks bad. Well, if these cables suck, then I guess they're going back. Can you try the original cable? The 3-foot, yeah. The 3-foot really doesn't seem that great either. It's way thinner. And apparently better. So 3-foot cable. Visually inspect the cable for missing center pin and test continuity. Center pin is there. Continuity. Click. Two-wire. I mean, that's 1 ohm. That doesn't seem too bad. We get a new cable, make sure it's RG58, and then it has that marking on it. Okay, so don't just buy the cheapest garbage on Amazon. Got it. I was under the impression it wasn't going to matter for this. Massive dip at DC sounds like it's not actually connected. But I just measured it at 1 ohm. Paul Guy, the sampling rate, in theory, should not be changing. I don't know what is going on. I have absolutely no idea. 50 ohm terminator at both ends of the cable. Anyway, for giggles, let's try a super duper crazy long one. I think we've already tried this one and it seemed good, but I didn't have a terminator then. Yep, that one's a rock star. So if I want to make long measurements, I got the cable. Cable's too thin to be any good. That's so weird. This is the good one. This is the bad one. I mean, I know that we're just seeing the insulation, but still. Jeez, that's irritating. Okay, I want to try something. By this or something, Hand Geek antenna medium wave. I'm not going to recommend anyone buy this thing from 1978. Yeah, wait, what? Yeah, that's what I'm saying. The 6-foot one is long and sucks, and the 3-foot one is thin and works. I want to try out this. So this is a video BNC cable. Channels. I've never tested it because, like, would I? I don't have anything that does this. Let's try red. Now that is a good cable. Bad cables, insertion, Last measurement. So video 785 ohms not really compatible. So this is one of those things where I've been trying to research this, but information is absolutely garbage, terrible out there about this information. My understanding is that the cable should be basically as low impedance as possible. It should be like 0 ohms. It should have no measurement. It is the expected load on the output caused, or the input, the expected load between the transmitter and receiver, and that those are different. It's not related to the cable. That's my understanding, at least. It is really hard to find, like, low-level information there. We're talking about impedance, not resistance. No, it should match the source load impedance, but those powers doesn't really matter. All right. I wish I could find any information about this at all. Try to find information about this stuff, and it's like, why do we use 50 ohms or 75 ohms? That's what literally every single article is. It's like, oh, this is why we use it, not what it is. It's irritating. All right, so there's that cable. That one was good. We can't test this one because I don't have a DVI breakout, so we're not going to mess with that. Then I got this one. This one's like way cooler because it's RGB and HV. I didn't even notice this until just now. This is an Extron brand cable. That's amazing. So I'm gonna guess this one's pretty good. We'll measure red again. So this would be another video cable. Also a Rockstar. Glad to know the info is difficult to find, justifies the value of my degree. All right. So my other cables that are way longer don't suck. It's just these 6-foot ones from Amazon. They're terrible. Here's another one just for giggles. I mean, I'm sure I could buy better cables. So I'm gonna have a video cable, it'd be fine. We do like 100 kilohertz less. All right. Transcription principles. I mean, that's a book. That's nice. This seems like the kind of thing where there should be a 1-paragraph answer. Wait, what? That one's fine. Hold on, this cable's good. This is one of the 6-foots. That one's fine. Wait a minute. Maybe there's a single bad cable. We get it working? We did. Yeah, we're moving on to testing some cables I bought, because some of them are garbage, it turns out. Okay, so this one sucks. So, bad. So set that one aside. All right, we're going to test every single one of these now. That one's good. One bad cable, not all. I mean, sucks I paid money for the bad cable. Now I want to test all my 3-foot cables. Makes a good and bad piles. Yeah, no, the bad one's different. Holy moly. I think his cables are going back. Actually, you know what? They are. They're going back. Nope, not keeping these. Alright, that was fun. First return, but that's why I kind of shotgunned the parts here and why I bought 2 lengths of cable. Okay. Oh wait, there's one more. Alright, hold on. Let me count how many there are actually here versus how many I bought. So I think it was like a 10-pack or something. Oh wait, the label might say 10 pieces. Okay. 1, 2, 3, 4. I'm gonna switch over to here. 5, 6, 7, 8, 9, 10. Okay, that's all of them. All right. Okay. I'm feeling like we should try and validate some other stuff now. How about that? So yeah, that one's definitely going back. How can we reliably, fresh from the reject bin, yeah. How can we determine that my 10 decibel attenuator is working? Because I feel like that wouldn't be a bad thing to check now. So far, the adapters, the joiners and splitters and whatever, those all seem to be good. But we might take a look at those more in a moment. Can you measure the impedance of cables, 50 ohm versus 75 ohm? You need a special device for measuring impedance. I was actually looking at one of those in the HP catalog, but everything that is weird, impedance, inductance, capacitance, that kind of stuff, they are 4-digit meters used. So, calibrate cable for 0 dB, put 10 dB. Oh, duh, yeah, okay. So disable auto ranging, and then just stick it in there. Okay, got it. So, disable auto range and reference track, range, down. Okay, so we are at no, range, ref level. Here we go. Okay. So there, it's 10 decibel per division, so it should just by one, oh, hold on. Okay, so we're at 10 decibel per division. 10 decibel per division, flat line, all auto ranging disabled. So, we should see this line move down 1 division here. Ooh, math. Okay. All right. Ugh, okay. All right. Is there anything else that I got that I need to validate? So what is this thing? This is, oh, no, that's the PVC wrap. Don't need to validate that. Okay, got the terminators, kind of validated those. Reefer caps, we don't want to put power to those. We've tested the banana jacks, adapters. Okay, we might be getting there. So you'll want to store the 0 dB cable measurement and subtract the attenuator measurement. Oh! Well, I mean, we could do that. That would be kind of cool. So, A to B, A minus B, Why is that weird? Let's hide B. So minus 10 dB. There we go. That's our reading. I adjusted the reference level because I'm an idiot. Hold on. A to B. No, A to B. And then A minus. What did I do? It worked. It worked. It worked. Clear A. View B. Why is A all wonky now? I don't know if there is a way to clear B. Oh, instrument preset. Ha! Okay. No, B was stored. What? Okay, I don't know. 1 meg. Here we go. Disable auto range and reference level track. Okay. A to B. All right, we're going to hide B. Oh, that was with the attenuator. Now it's going to overload. Range. There. Down 1. Come on. You know what? Auto range, whatever. And auto everything. I'm just, okay. A to B. Hide B. Take out thing. Attenuate. Stick in attenuate. A minus B. Bam. 10 dB. I'm on marker. I can measure a 10 dB drop across the frequency range. Okay, jeez. Ugh. Good BNC cables are $12 each. Yeah, I probably spent less than $12 for the whole bundle of cables. Not saying that was a smart decision. I'm saying that's how we ended up where we are. All right, I'm happy with this validation. Oh, we can probably turn off the multimeter now. All right, let's check all of the 3-foot cables to make sure those aren't garbage. Because I feel like I kind of need to do that now. All right, so we already did this one, but there it is. That looks right. I'm going to let it auto everything. Okay. Just because no one said anything in a while, I would like to confirm, because it's a bad internet day, we're still live and still good, right? Just making sure. All right, that was looking correct. How many cables is this supposed to be? 6-pack. 1, 2, 3, 4, 5. I'm missing one. Where did I put it? Oh, it's probably around here somewhere. Not live, no. Ah, darn. Okay, we're good? All right, thank you. Okay. Oh, there it is. It's on the back of the thing, because, yeah, the stupid thing. Mod output. Okay. All right, that's looking good. Ooh, we could mess with that today. That would be kind of fun. Video's live chat is a replay. Okay. All right. Dude, these 3-foot cables are way better than the garbage 6-foots. Yeah, these I think I'm going to be fine with. All right. I do have a question for those of you who are of the EE persuasion. All right. Do you know of a good GUI for doing SPICE simulations for Linux? Yep. 3-foot cables pass. Okay, perfect. LT spice can run on wine. Author of command friend just trying to integrate spice with it. Don't know how far he's gone though. All right, it's a great starter. Web based, not web based. That's not acceptable, and it also must be spice based. Hue spice.
100. Am I all screwed up again? Let me get a drink. End of line.
It didn't fail. Thank you, Chloe, for the 100 bits. KiCad does have a spice output. I don't know, does it simulate spice in KiCad? Because I'm not sure about that. The thing that I'm looking for is the ability to drop probes on arbitrary points of the circuit. Q spice picks up where LT spice left off. Okay. I am highly interested. That seems like it could be the answer. Acquiring a download link requires emailing these. You gotta email them to download it? When was this written? A year and a half ago. Okay. KiCad Spice recently added, kind of in early development. Okay. You can just run a VM to run LT Spice. I could, but I would really, really like it to just be Linux. QSpice looks great. All right. I will look into that. All right, I'm just glad that there is one. Last time I looked, there wasn't really much, and it sounds like, yeah, that's just, yeah, there. Wouldn't we all, yeah. Hey, it's bad enough that I recently started using Word 97 in Wine, just because that fit my needs best, so, all right. All right, I am ready to reveal a thing. Okay. So, how can I do this? Now that we know how to do this, I think this would be really fun. I'm just trying to figure out how I can, because I only have one adapter for this, I think. Give me 1 second, see if I can scrounge up another RCA adapter to BNC. I don't think I can. I think I took them all home. In theory, there should be more here, but they aren't. Because that would have been smart. Yeah, I don't see any. Okay, well. Let's see. Clippy made Mutant Office 97. Yeah. Let's see. I like clip art. Word came with a lot better in modern versions. I'm not after that. Word 97 and Wine, you sick. Yeah. So it depends what you're trying to do. Many components models aren't portable between Spice programs. Oh, I didn't know that as much. LT Spice was optimized for Wine. This point just use Markdown? No, I specifically can't. Okay, I'll explain the Word thing. I'm using Word 97 because comments in LibreOffice suck. What I started doing is using comments in the word processor software. So boring. To mark what my video shots are going to be. So, like, I'm saying, you know, let's say a video about capacitance, you know, I use a DIR EE-DE5000, and then I would have a comment on that says tight shot of LCR meter, all right? So the idea here is that I can highlight the text of the script and then have a comment that points to that. But I specifically want the text to be highlighted because that has utility, because then as I'm scrolling through the document, I can see which parts of the text are highlighted and which ones aren't. And if I'm doing a talking head script where I'm, sitting behind the table looking all nice and proper, it means that I know which parts are going to have video and which parts are just going to show me. So being able to comment like that is very powerful. The problem with LibreOffice is it puts all of the comments in a column and then crushes them to the width or to the height of the page when you get too many of them. So I couldn't make that work because I need the list of comments and then I need the actual script. Another benefit so like the text in the document, go to apply a comment, and then it just opens a new window panel in Word 97, and then the comments are literally just a line-by-line text document. It is flawless for how I want to use it, because I can make the description of the shot as long as I want. So yeah, I don't know what you guys missed, but long story short, comments in LibreOffice suck and are too cramped. Comments in Word 97 are perfect. They're amazing. That's what it comes down to. Anyway, all right. Hold on. I want to measure a thing. So I need some stuff here. It's not going to be more. I don't need anything to be different. Like Word 97 works. That's what I'm saying. Is that it doesn't matter. Word 97 is perfect. All right. Oh, well, that's intriguing. I don't like that, but okay. So I'm just going to real quick connect these two sets of probes together. Boop. All right. So here is a measurement of the two sets of clips going together. This isn't perfect, but I feel like that's not too bad. I'm going to store this to B. Okay, we've disabled auto ranging. Now, I am going to switch microphones. All right, and I'm doing this for a very particular reason, because I am going to. Oh man, that's a pain in the butt. I will be right back. I need a cable. All right, I got a cable. All right. Now I am disconnecting the probes from each other. I am clipping onto dut. Oh, maybe this might be a little more difficult than I was anticipating. Uh-oh. Bad dut. Wow, okay, this is actually a lot more difficult than I anticipated. 1 second. I have a lot of room sound because I'm currently using the microphone built into that camera. Okay. There's that, and then... Yeah. Yes, I'm intentionally withholding Y for a little while. One moment. Okay, now, baseline. Okay, new baseline, A to B, okay? Disconnecting the cables, connecting to DUT. Alright, ooh, that's weird. It could be partly due to cables, but here we go. So we have a minus 10, minus 9. So minus 10. Oh, you know what? I just realized that doesn't actually stay. Okay, is it back? Is it back? Back? Okay, one moment. Bad audio for a second again. Okay, because I think you guys missed the reveal there. So the DUT was not a mic. The DUT was this. This is a DIY attenuator that I built. The reason why is because the entire stream has actually so far been done through one of the Rode microphones. You know, audio's bad because it's going through the mic behind me. Now, why do I need an attenuator? Because you guys remember when I've used the Rode mics and it would clip constantly? Well, I built the attenuator to plug the mic into. So now, this is the lapel mic that I use with the Rodes. Don't take that cable through airport security, yeah. So, the Rode mics are now usable, essentially, again. Yeah, so that's it. I don't know why you can barely hear what I'm saying. Audio bad. Don't worry, it's just there. Just fine, whatever. Apparently no one gets it or cares. So whatever. Just stop complaining about the audio. Oh my gosh. You can't hear me if I unplug the microphone. I give up. Anyway. So yeah, the whole stream's been through the Rode mic. Let's reassemble this driver speaker, and then we can go on to the next thing for today. Trying to think if I want to move the camera over. You know what? It's not like it's that hard. Now, guaranteed not to get blasted with full tilt white noise. I mean, yeah. I'm going to go back to the Sennheiser. The Sennheiser's better. This is just like, optional. On a scale from 1 to ARG, how is today going? You know what? Actually, for being a sponge Wi-Fi stream, I feel like this is going pretty good. If the dropouts were half as much, I would almost consider this viable. All right. So all we're going to do is just reattach the drivers so that I can have this speaker be functional again. Still looks better in pre-H.265. Yeah. Yeah, that is the massive downside, is that the bitrate has been extremely hampered. But at least I now know with H.265, the stream can still be enjoyable at a lower bitrate. Sounds like Stockholm Syndrome. It sounds like it would allow me to stream when data go bye-bye. So the good news is the data is going to reset before the next stream. The bad news is we only streamed like 2 weekends on this data. We have no idea how I use so much data. Quality is still good despite the dropouts. That is shocking. H.265 is magic. Tells me I should probably reduce the bitrate some. Go up to more quality is more better. I mean, yes. So I gotta balance it. So I don't know. What I could do is on the average stream just have the bitrate be slightly reduced and then bump it up when it makes sense. There might be protocol overheads. I don't know. I should actually check it at some point. Maybe. Yeah, I just looked at the positive mark now that I know that's actually on there. PC Mag says no, it's a single 5G connection. The other one is Wi-Fi, and no, I'm not going to try and bond through them. Oh my gosh, the latency nightmares. Finds the dropouts more annoying than worse picture quality. So the gray ones, I mean, that's what I'm thinking. I might be able to fix some of the gray dropouts by just reducing the video quality. I'm gonna be totally honest. Today, I was gonna try streaming from my phone tethered in case it was the Netgear thing, but then, you know, no data. So that didn't exactly work out. And up it as a month goes. I mean, I could. This is kind of a pain. Yeah, I'm not going to try and bond the internet connections. That requires an external server of some kind. I mean, I could do it to my server at home, but it's not worth it. It's just not worth it. Tie the bitrate to chat participation. No, because then you guys will just start spamming it all the time, and then we'll be able to stream for half an hour at 35 megabits per second. All right, that's reassembled. And now I'm putting the speaker grill in wrong because I tend to run these on really high shelves, and having the tweeters be closer to your ears is better. So I run them upside down. But all right, there's that. I'll just put it under the desk for now. Alrighty. With the office somewhere with good internet. Do you see the things I have in here? I don't want to move. Moving's rough. All right. That went so much smoother than I thought it would. I thought we were going to have to spend way more time on all this stuff. Okay. Trying to think of what we want to do next. I got half the stream left. Man, this is crazy. Okay. So we qualified all the cables I bought. Oh, you managed to stream on DataCap 5G. Yeah, it's stupid. So, eventually, maybe someday there'll actually be Google Fiber here. That would be cool. Maybe someday. Yeah, it is 4G. It's not worth correcting, people. Play with new toys. Well, that's the thing. We kind of have been. The newest toy. Okay, so if I'm real, right now, what I want to do is organize capacitors. That's the thing I want to do right now. But that sounds insanely boring on stream. Poll timer is too short. We could actually bump that up now that we're not doing Zork. Would you guys want that to be like a minute per poll?
100, it might not be worth you correcting people, but we're pedantic.
End of line.
Chloe, thank you for the 100 bits. Lily says something about her technological level, just how even a $200 laptop is good enough for most people. Yeah. Japanese landlord, Google Fiber for extreme. One of them is way more exciting, and it's going to be what you guys want to do, and I almost don't want to tell you. Video froze again? I mean, when will we GPIB program the essay in this gen? Yeah, so that's the thing. That's what we could do, but it complicates things. So we could pull the SIGGEN down, all right? And we could try programming arbitrary waveforms. So we could try doing that. I don't know that there's a whole lot to do with the spectrum analyzer over GPIB, though. I've been thinking about this more. It really seems like the spectrum analyzer is a kind of fuzzy human feels good output unless you're doing a peak measurement with counter, in which case you still need a lot of manual input. It seems like at best, I would to query the counter register every now and then over GPIB, but I don't know, man. You download a capture from it. I am unsure. So I didn't read through the whole GPIB programming part because it's long and really dry. So yeah, I think you can screen capture over GPIB. Well, I don't know about that. What would what? No, that's not possible. It can barely drive an XY plotter. There's no way it can screen capture. Even the 16500C, you have to do FTP to do a screen capture. And the way that it does it is stupid. I don't know. So we can either try to program the SIGGEN for arbitrary waveforms, or we can organize capacitors. And sadly, the one I want to do is organize capacitors because I'm really tired of stuff being a mess right now. But that's boring to do on stream, so we should probably just get the SIGGEN down. All right. Well, I really don't want to take the spectrum analyzer down either because it weighs 88 pounds. So I'm not feeling like moving it unless I absolutely have to. There's a power cable plugged into this somewhere. There it is. Wow, I got way over into the middle. Okay. All right. And you need reforming. No, so what I'm talking about, Cart, you weren't here at the beginning. I now have 3 of these, and I'm trying to sort all of my parts, my components, capacitors, resistors, transistors, all that kind of stuff into these so that they're like easily accessible. but it's going to take forever. I was going to do that this morning, but then I accidentally spent the whole morning making that attenuator for the microphone. That took so much longer than I would have guessed. The only reason it took so long, okay, I would have saved like a half an hour if it turned out that somehow the Rode microphone has a connector going to the 4th pole of the cable, and that was messing it up. I was using a 4-pin connector, so that was the reason why there's that really long male connector on there. It's actually a male-to-male joiner, and I have a female connector on my thing. It was stupid. It took forever. Anyway, SigGen. It generates SIGs. You know what could be fun? I should go grab the speaker. We could plug the speaker into this thing and do like weird stuff. You know what? I'm doing that. I'm gonna go get the speaker. Unless you have a production test, GPIB does not make sense. No, there's lots of reasons GPIB makes sense. TMK DK, check this out. So I just turned on a multimeter down there, and let's say I want to measure the voltage of a battery here. All I'm going to do, it's on a voltage measurement right now. I'm going to plug this here and there, and well, now you can see it's 9 volts. Shows up right there on the stream. I don't have to point the camera at the multimeter. GPIB has a way more utility than just for test equipment, for test procedures. But also I have it set up for test procedures. You know, I kind of want to do that today. Actually, ooh, okay. We'll do an ArbGen thing on here, and then we're gonna, if we have time, I would like to test the cap reforming on this computer, because I realized we've never, you know what? No, screw that. We're doing that right now, actually. We need to do this. Sorry. Change of plans. Look at this giant capacitor. Let's reform it. Okay, so for those of you who may not have been here a while ago, all right, I need to do some stuff off camera. Where's the condenser tester? It is in the other room, but this is low voltage. So this is 75 volts. That's higher than I can technically do with one power supply. I could put them in series, but I don't want to do that. High capacitance or voltage, yes. It's 75 volts, but we'll do it up to 50. But I am going to need to modify, okay, let me explain this. If you weren't here, was it years ago now? I don't even remember. Using my equipment here, I wrote a program that runs a web interface that allows me to program in the specifications for the capacitor, and it will slowly charge the capacitor, limiting the current by using my programmable power supplies and then measuring the outputs of it, like the voltage and other stuff. And then it will slowly bring up the voltage on the capacitor to properly reform it. We haven't set that up on the new stream computer or on any of the new DMMs or anything, and I think that would be prudent. So I think we need to mess with that. But for this, I'm going to want to actually log into GitHub. So I need a moment to do that. So github.com, and I say log into GitHub because, surprise, surprise, I'm always logged out of GitHub. Always. Okay. Hey, look, it's a background. And then, boop, I'm gone. You can still hear me, but you can't see me because I am signing into GitHub right now, and I don't want you seeing any of that. So I just need a moment to work on that. All right. Virtual lens cloth. It's one of my favorite things you did. It even graphed. Yes. Yeah, it's pretty powerful. Okay, verify your identity. Oh, GitHub's got like a whole thing where you got to type in numbers now? That's ridiculous. All right, and I am good. Okay, now I'm logged into GitHub, but I actually need another moment because I need to generate an SSH key on this computer because I don't think I have one. No, I do have one. Okay, so cat dot SSH slash ID underscore RSA dot pub. Never mind, I didn't actually do. Oh, you know what? I just realized. You can see this because it's not like I'm gonna type it. As long as I don't show you the screen, it'll be fine. So SSH dash keygen. All right. Yeah, save the key. What on earth? Why is it something weird? It's not going to be RSA 256. We'll try this. This is strange. SSH ID, that thing. No, that's the okay. Dot that. Okay, this is confusing, but okay, there. Stream getting stuttery? It shouldn't be. Okay, settings. SSH is going to make me type in my password again. No, it's not. Okay. Stream PC. Okay, I'm now regretting using HTTPS to download some of the stuff from earlier. Okay, so now I can do that. Okay, modify the GPIB web code. That's why I'm doing this. So, my gosh, why does GitHub always make it so difficult? Okay, I think we're good now. All right, so one moment here. Oh, hey, look, it's me. All right, we're going to go to the still for this view for a bit. All right, and then, not that, that. Okay, so we're going to go to GPIB. Boom. Cap reforming web. This is the one we want. Okay, so this uses GPIB and capacitors and Flask and web pages and all that fun stuff in order to reform a capacitor. So the first thing we're going to do, we're going to clone this to a local repo. I'm going to open a new window here. All right. So git boom. And then git clone bam. All right. Now, we're going to start out by just running the old version of this. We're not going to modify anything because I don't want to mess with that yet. But at least it's new and I can burn it really. And you didn't see the whole thing.
Alchemist said nobody noticed at least CHEER 100.
All right. Well, that was fun. Whee! SSH key. Yes. Over. Yes, Ben. Thank you for the 100-bit. That wouldn't have been so bad. It had been the private. Stream PC. That was the P. That wasn't the public key. I mean, the public key was there too, but you know, one without the other. I mean, whatever. Okay, that's new. Let me go ahead and close that terminal, and I'll just open a new one after, I think. All right. All is going to be right in the world in just a moment. Did I already clone that? I mean, I think it'll still work. It's, I mean, by idiots, plural, I mean me. I'm the idiot. Okay, there we go. Hey, look, it's back. Wow, crazy. Get, pull. Okay, I am author. Fun, so much. Okay, get reform 2. Let's start this proper. So somewhere around here should be the number 5,000. Let's find that. Why is there no number 5,000? Okay, where's Flask? Flask. Okay, Flask. App the reform script. Oh, am I supposed to put the port there? Probably. Okay, let's figure this out. So we'll go to stream integration, and this, and then the API HP, then in this GitHub, so it's always safe. Okay. Wait, where do I set the port? Am I not setting it? That's weird. Where is it? Okay, there should be a connect function. Where is that? And header, pull check. No. Where is it? Host. No, just Control F, port, web thread, self, host. Okay. Connect. Yeah, the port is there, so it's 5001. Okay, well that means there won't be a collision.
CHER 100.exterminate. I am italic. Exterminate. End of line.
Machenko, thank you for the 100 bits. All right. Oh, this time it works. One? I don't know. How dare it? I don't know. All right. I think this. Okay, when I clicked the terminal button, I was trying to find this one so I could stop it, because that is stuff, and we cannot run simultaneous GPIB things. So also, fun fact, okay, I was going to integrate the GPIB measuring stuff into the main stream script, and I realized specifically for this use case, so I needed to not do that. So, it's supposed to be bad sample rate. Oh, I don't know how. Can you now query the DMM for units? No. Reform P2. Okay, let's see what this does. Did it work? Let's find out. Wow, that's tiny. Okay. It might be working. Okay. So I need to kill it. All right. Querying units really, it is not trivial. I'm not just like, no, I don't want to spend the 50 doing it. It's going to be like 2 hours just to do that. I'm not kidding. It's going to be bad. 3478As. They're really, really rough. Okay. The 34401A is supposedly address 7. I think I changed it. It's 11 now. So this is address 11. And 6633, that is the higher voltage one. This is now address 7 still. Okay. So I kind of almost swapped those. So 7. Did you remove the key from GitHub? I did, yes. Okay. Now those accessible. I don't know what you mean an SSH 250. What? What are you talking about? Okay. We can run this now. Getting public keys. Oh, Baltazar. I regenerated it. New key after I killed the old one. So one generated a new key and then did it. You can just query pub keys for any user? That's horrifying. I mean, there's no reason not to have that, but yeah, okay. I don't like it. Okay. Reform V2. Let's go back to here. F5. So, hold on. Let's look this up. Capacitor reforming. Screw you, AI garbage. All right. Oh, cool. We show up that early? That's not what I'm looking for. And on the first video hit, I mean, I am signed into me. Okay. Capacitor reforming. This is what I want. Okay. I wasn't kidding. I joked about this, that every time I need to do this, I want this image. I made this image. This is mine, but it's easier to find it today than anything else. Because this is it. This is how you do cap reforming. Stream lag, what were I going to say? Created a new pub key or private key on the using the same encryption algorithm. So it's all fine, or hashing algorithm. So it's fine. I appreciate you trying to look out for it, though. Okay. So we have a voltmeter, no, ammeter, that's measuring amps, right? Hold on, let's look at the code. I don't remember what it's doing now. Let's see, DMM set current. Okay, so we're measuring current. We're not measuring voltage, so we're calculating voltage based on current. So, okay, let's do some stuff. Boop. Alrighty. Who else reforms capacitors? You're saying I'm the only weirdo who would do this? I mean, maybe. It's a shame I can't use this one because it's way more convenient. Okay, so the power supply output. Hold on. Ground from this goes to this. Okay, so I need this one. Okay. All right, we're gonna set up the reforming stuff again. Let me just pop this up here for now. All right, what is that? That's ESD bags. I need this. All right, so we're going from negative on power supply output to ground on the multimeter. Okay, and then we need positive from the multimeter going to essentially a resistor, and that will be a 220 ohm resistor in this instance, which I seem to have lost. That kind of is annoying, but it doesn't matter that much. So we're going to go positive here. Actually, I'm going to go negative here. It makes it weird, but it'll make more sense in a moment. Negative there, actually, well, nah, we'll leave it like this for now. Okay, feel like I didn't remove logo from the YouTube video screenshot. I mean, they didn't. Oh, you like that they didn't. I mean, it's annoying too, so. All right, going to that. Let me grab a 220 ohm, you know, for giggles. No, that's not. Or is it? Let's measure this really quick. Bottom 3478A. this resistor is 1.1K. That's fine. Whatever. Close enough. All right. So the way I set this up is I'm just going to clip these two gator clips onto the resistor. That's all I got to do. And then to make it so that they stay in place, slide these up. I'm going to add a Velcro strap around here. And boom, that's the resistor part. We need the resistor to current limit. This is something I get asked about all the time when I actually talk about capacitor reforming. So we need to limit the current, and this is a current programmable power supply. So you'd say, oh yeah, limit the current with that. Except that the resolution of this doesn't go high enough for what we need for reforming. So this is unacceptable. So we have to have a current limiting resistor here, and then we do math to measure we measure the current, and then we do voltage calculations based off of that. But long story short, we must have the resistor in here to set this up correctly. It's really annoying, but we must have it. So, all right. Then it is negative side of the capacitor to the positive side of the, hold on. Oh, wait, I got the instruments backwards. We have current measurement here. Okay. Wait, dummy. Okay, one moment. Power supply, positive out goes into the resistor. So this is my positive that goes into the capacitor. Okay. Then the negative from the power supply goes into the current measurement of the multimeter. The current measurement of the multimeter's negative side is the negative side of the capacitor. So this goes into the negative side, this goes into the positive side of the capacitor. Now, why are these banana jacks? Why wouldn't I have clips? Because the capacitor we're going to look at is a screw terminal cap. And on these, you can just straight up plug. Whoa, these are so big, the banana jacks are actually loose in there. That's insane. I have not encountered one this big before. Holy moly. It's too big. What? They're just loose. Okay. How do we make that bigger? Can I use massive gator clips on there? Okay, let's jumpstart our capacitor. This is gonna be stupid. Popped off. All right, there. And there. Okay. So here is the cap, all connected and ready. Okay. So we're not going to touch anything on here. All right. Actually, I think we can see that the capacitor has a 1.5 volt charge on there right now. So, all right. That was a 1K ohm resistor. So let's go back to this. All right. And we're going to go back to here. Okay. So our resistor is 1K, so 1,000 ohms. All right. Our target voltage, let's just do this to 15 volts for now. I'm going to set our current maximum to 500 microamps for right now. Just have it be really short. My power won't go up to 75 volts. It'll limit it. It's going to be. We're going to go ahead and do that. And now I'm going to zoom this out and I'm going to hit start. So everything should get configured. And it's not working? Hold on. What happened? Kill reform. Back to cancel. What happened? That works. Local. Refresh. I only have you in a video just to annoy those people, so, don't worry. Okay, 1K. Target voltage, 15. I'm just going to slowly ramp it up. 500 microamps. Okay. Start. That's looking... Okay, this time it worked. Sure. Why not? Okay. So our voltage on the power supply is 2 volts. And then our current reading is 300 microamps. So that should be stepping up the voltage. All right. This is working. Now, isn't there... Wait. I had a overlay for this? I don't. I cheated. I do not have a web overlay to do this. Wow, this is slow. This cap needs to be reformed. Although very, very much limiting how much current I have. All right, I'm going to go to OBS. I'm going to add a new browser source. Cap reform. Boop. And then 1920, 1080. All right, so that's that. Why did Alt not work? Oh, because that wasn't Alt. Okay. I think I can copy and paste. I can only paste a reference, huh? That's a problem. Because I think if I crop this... Oh, no, it doesn't crop both? Perfect. Okay, beautiful. All right. So that is the current state. And then I need a group. One moment. Group selected items. Cap reform. All right, so now I can show or hide that whole thing. And then this, I only want these charts. And there's no... Oh, there is a color source. Sweet. Okay. Yeah, let's go ahead and have that. That's our color source. I'll put this here. I'm going to do this. I might make this slightly smaller here. Okay, sudden white reminds me of active, the way active desktop would crash. Oh gosh. Okay. I don't know what that line is. I just need to crop this down slightly more. Okay. Okay, now filter, add, color correction, whatever, opacity. Right there. Okay, close. Okay, so that'll work for that. Now we're gonna stop this because we're running this super duper slow. We can have this go a lot faster. It's almost time for second stream for all the extra stuff. So I've actually done a video, not quite describing how the cap reforming software works, but how cap reforming in general works. So we are reforming that capacitor right now. That is what's currently happening. But what I'm going to do is I'm going to go into the software and I'm going to stop this, kill reform. All right, back to setup. I'm going to set the current maximum. I'm going to leave it at 2 amps. I'm going to leave the target voltage at 15 volts. The resistor is 1K and go. So this should move a lot faster now. So I'm going to go ahead and hide the screen capture here, because in a second the other thing should show up there. There we go. All right. Okay, if I remember correctly, is it 200 or 150 microamps for the trip? It is 150 microamps. So when it gets, oh, there we go, current limits in right here, current limit. When it reaches 150 microamps, then it will go up to the next, thing right there, so we can see, and then it slowly drains down. I thought I set the max current to 1,000 or 1 milliamp though. I'm gonna kill this and make sure that that works. It's 1,000. Resistor 1,000. Target voltage 15. Start. Okay, there we go. That's better. And there is no way of setting the min in software. Okay. All right. This is a really good example of a capacitor that needs reforming, by the way. Like, really, really good. Now, I am curious here. So I'm going to use the 3478A to measure the voltage at the capacitor, which we can't do normally. Because I want to see what that looks like. But I think we're calculating the voltage. Just want to make sure I don't disturb this too much. So I got it backwards. So there is a drop. Okay. So 3478A says 525. Our math says 526. Dude, the math is perfect. Who would have guessed you could do math? Crazy. All right. I wonder, I don't know what the minimum current amount that these can measure is. So I might only want to use the 34401A here. Does not look like Spectrum Analyzer. We did that at the beginning, and we found out a lot of my cables suck, and that I'm going to be returning some, but we were able to do it. It went slow and fast. We kind of got all of it done. And then I realized I hadn't got my capacitor reforming stuff set up before. Also, Poot, I don't think I've seen you on stream since a while ago. I wanted to clarify that I was not mad at you the other day. I was just really trying to be on track with the filming that I was doing. And I was a little frantic because it felt like I wasn't going to get it done. So I was trying to make sure that I only did the things that I absolutely needed to do. So I just wanted to be clear, I was not mad at you. And I appreciate the recommendations that you gave. It's just I had to be choosy about which ones I actually looked at. So no need to be sorry. It was not your fault. I was being a little short there and curt. So my apologies. So what characteristic can you measure that shows reforming worked? So you see how long this process is taking here. We are currently at 6.5 volts right now. It is going kind of slow. All right. So let me bring up the full size chart on stream here. I don't know if I actually have a thing for this. So can I just copy? Let me rename this. Capture right. Hold on. Desktop right, and then paste reference. Okay, and then I'm going to make this one Control F. No, Control R. There we go. Okay, so this is whole desktop, but it needs to be under everything. Desktop full. Okay, squish this down a little bit because you can't see the webcam. Okay, let me hide the reform overlay as well. Okay, so this is the full page chart here, and this full test data chart tells us. So if you look, you see this is the voltage of the slowing to meet what the power supply is set to. So these steps here sorry, I don't know how much was lost there. Can a thermal imager see the cap slightly warming up as it reforms? That's a good question, Poot. No, it should not be able to. The whole reason we're doing this slowly is to prevent the cap from heating up. Anyway, so actually, you know what? There is... I need to look at the code for this and then adjust the OBS thing, because we can increase the viewing window for this to show more samples. So like 1,200 samples here, and we can see this a little better. I need to do that on the OBS side. So we'll look at that in a moment. Anyway, so you see these ramps and the steps here. We are currently at 8 volts on this reforming test. If I kill this reform test, so we're going to stop this, okay? We're going to go back to setup. I'm going to enter in all of the same values. So the resistor is 1K, and I'm setting the current maximum to 1K, and our target voltage is 15 volts, okay? We're going to start reforming. Okay, now I want you to watch this chart here. We're currently at 7 volts, okay? We're at 300 microamps, and then in a second, it will go down. Why did it start at 7 volts? It's like half of the range. Was this like already there? We were at what, 8 or 9 volts? Hold on, let's go back. Kill reform, 1 moment. Back to setup. Maximum current, 500, okay? We'll do this. Resistor, 1000, target voltage, 15. Okay, we're gonna really short it on current. Start reforming. We should see way more steps here. Yeah, there, it like instantly gets back up to there. Okay, so you see how quickly it ramps back up to 7 volts here, all right? That speed at which it ramps back up to the voltage that it was working at tells you that the dielectric has been fully rebuilt up to that voltage. It will not use any more current to rebuild the dielectric up to that voltage. So when we redo this test, sequential time, so we run the full test and we run it again, every time we run it, it should be faster because it has rebuilt the dielectric up to that voltage. So there isn't like a yes-no test that we can run, but we can see the performance characteristics of this and how it runs like that. Massive capacitance and no bleed resistor. Ah, you say that, but I'm going to hit kill test here. All right, there you can see that voltmeter is on the capacitor. Kill reform. I guess I was doing it a little too fast. Why is that not dropping as quickly as I would have guessed? Oh, I think I know what it is. Is output off? Hold on. VSet, local. VSet is 0. iSet is that. Okay, hold on. On. Disable. iSet 0.5. There we go. Okay, so I'm now discharging the capacitor through the power supply. You can see it's sinking 600 milliamps. So we're going to just do that. I forgot that running kill reform does not do that. When the thing actually stops, it will discharge the capacitor through the power supply using current limiting. Okay, so we'll fully discharge that and then run it again. After we reform this cat, we'll be putting back in the equipment came out of. No, this one was sent to me as just like a lol, here's a big cap. So I don't have anything it goes into. It's just a good demonstration cap. The audio is too choppy to make out what you're saying. Oh, that's unfortunate. Oh, okay, so it failed a bunch there. Okay, that's... Sorry. This could take some time. It won't take that long. All right, let me go back to setup. Philip sent it. I believe Philip did send it, yeah. All right. Set the maximum current to 500. Current. Oh, I do have a current minimum. I just can't read. Target voltage. Okay. So that is at 2.3. We're still, yeah, so this is going to take a lot longer from here. Okay. Now I'm going to restart the test. Start, and we'll see how quickly it ramps up still. Oh, that is not very fast. I think this cap may not be good. Or it really needs the snot reformed out of it. Let me look at my cap drawers really quick. Let me show you a new cap. How expensive are those caps? That one's probably a $40 to $50 capacitor. So, much expensive. I don't have any like good monster caps in here. This is 10 UF, 100 volts. No, this is 10 volt, 100 UF.
CHER 100. I not want any cap that uses not as electrolyte. End of line.
Okay, here we go. 50 volt, 10 UF. I mean, that's not a lot. How much nanofarads that cap have? It's not measured nanofarad. It's almost measured in farads. Actually, it probably could be measured in farads. I think it's 39 farads. Because it's a 39,000 microfarad capacitor. Don't mind me, I'm just digging through floor storage because I know there was a cap down here. I think we've reformed this one a bajillion times. This is 100 UF, 160 volts. Hold on, kill reform. Okay. See time constant, 39 seconds. I'm not sure what you mean. It's a million microfarad equal volt. Oh, I didn't realize it was that far off. Units are like, crazy.
CHER 100. Never fear, I'm here. Did Ben break it yet? End of line.
Ben, thank you for the 100 bits. Moonwire, I did catch your 32 months tier 1 ago, 2 hours ago now, right? I hope. Anyway, back to setup. Hold on. Let me do this really quick. I'm just gonna clip on to this capacitor down here, which I believe we have already reformed. You know what? I just had an idea. I could totally 4-wire measure this, but I won't. Oh, I need some smaller clips. Okay, negative, positive, there we go. Okay. So I think this one was, again, completely safe. 100 UF, 160 volts. So we can do full scale voltage on this, but let's say 50. Yeah, let's just do 50. Now let's do 25. And by 25, I mean 20. Okay, resistor, 1000. Current maximum, let's do, let's leave it at 2000. Okay, I'm going to start reforming on this capacitor. We have already reformed this capacitor before. You see how much faster it just reached? 20 volts right there? That is what speed, or what a good cap looks like, okay? So that cap's probably fine. I don't remember what that came out of, but that thing's probably fine. So that's what a quick reform looks like. Poot, that is why I built this. How many microfarads is this one? It's 100 and it's just 100. And how long will that take? I don't have a time for that. So what I'm trying to calculate to just charge the capacitor. Also, I'd like to point out the current is dropping, or the voltage is dropping. 0.1 second versus 39 seconds RC time constant. Okay. You're making me think I should add that. Dang it, Wizard Tim. We have an hour. We're about to add math to this thing. Ugh. Hold on. This is going to be awesome. Pretty sure this is a simple equation, right, Wizard Tim? All right. Yeah, we're going to go back to the right side. So sorry I brought math into this. No, this is actually really good. So here's the thing. These little windows here, we could totally have one that tells us the percentage deviation per charge time. So we could calculate the health of the capacitor as a percentage of the expected charge time. So let's say you're saying the RC time constant is 39 seconds. Is that for what? To get to 15 volts at 39,000 microfarads? If I calculate that out per segment here, and then we measure how much time it actually takes, we can use the time that it takes, which will go over, reach 63.2% of the set voltage. So why 63.2%? So anyway, let me finish explaining what I'm thinking, okay? Let's say it takes 100 seconds to fully charge the capacitor, at 2 milliamps here. That's what math says it should be. This one takes 120 seconds. So it was 20% slower. We could say that it was at 80% health. We do a difference there. And then that was the 20% extra time was what it took to reform the capacitor. Then we could, is how the math works. Okay, so I could just estimate it from there. Because 1E or something like that? Okay. Anyway, so what I'm saying is, the first time we charge the capacitor, all right, it is not a perfect capacitor. It would have what you would think of as really bad leakage current, but that current is actually being consumed, turned into heat, and building up the dielectric oxide layer inside the capacitor. The second time you charge the capacitor, it won't exhibit that. So if we calculate this, and then we compare it to how long it actually takes, we can figure out a percentage variance from an ideal capacitor. And then as we run the test more times, we can see how close we get to the ideal capacitor. And then we can come up with a cutoff, like if it's below 20%, or if it's greater than 20% variance, then we could say that cap fails. You can also plot the ideal slope on the graph. I could. If we're doing that, I'm rewriting it from scratch. Not because that sounds so difficult, but this code sucks. It's so bad. Oh my gosh, it's awful. It's really bad. It's close to academic paper. I tend to get that way sometimes. Vio, no, I don't. I just have to calculate it per step. And then we just average the steps. Rewriting Go? No. See, the problem was this was the first program I ever wrote with Flask, and I didn't know how to abstract Flask away and make it not garbage. And I kind of learned in the middle of this, and it was terrible. From an initial charge voltage of approximately 63.2%. Discharge approximately 63.8%. Wow, that... Huh, okay. Undoubtedly, if you get that data from those measurements, it would be clear proof of exactly how much reforming capacitor experience. Yes, exactly. That's what I want. That's why I think that that is a super ridiculously cool way to do this. I didn't... This never occurred to me. But this would totally give us a clear-cut way of determining the reform amount. And the quality of the capacitor afterwards. I mean, we could just measure leakage current because directly that's what it would be, but this is an indirect way that is more beneficial, I feel. Okay. So I want apparently a weird value. Okay. So time constant, related to RC, cutoff frequency. So we would have to calculate the cutoff frequency. I think you should also rearrange the formula and calculate T in real time without the voltage steps, but a continuous voltage slope. So, I think what you're saying Wizard Tim. It would make sense to do. So I think what you're saying is the whole stepping is stupid. Still getting over my Cisco routers. It is not. My apologies, but no, I hate networking. And no. The problem with a continuous voltage slope is that we would have to it can effectively make it a continuous voltage slope. Kill refresh. Current maximum 200. 25. Sorry about that. We can make it a mostly continuous slope by narrowing the gap between the maximum current and the minimum current. Due to the discrete voltage steps, you will only get close to discrete data points. If it's continuous measurement, get as many points as you want. So we can do this. As you can see here, it's a little wonkier. I think I need a bigger swing than 50 microamps, though. Oh, one moment, really quick here. Let me go back to capacitor reforming, static, JS, view. Hold on. Get element. Stupid JavaScript having get all over. Wait, it didn't show up. I'm pretty sure I added a notation-wise, it would still use steps, pretty much exactly what you're doing, but it calculates T would be much more complex for continuous steps, small steps. Oh, so is what you're saying. Okay, back to setup. Hold on. So let's say we do a 2 milliamp or 2 milliamp resistor 1K target voltage 15 start. Okay, you're saying still leave the code doing the really big steps, but then we essentially start with this voltage and whatever the current voltage is, and we just use the average. So we just take the total time of the test. We throw out anything else. Just take first and last, essentially. Okay, that does make more sense. Anyway, maybe I'm wrong. I swear I had a way of changing the number of steps. Versus 0, you actually want just time and cap for charge. Not first, but last moving average. Moving average of last X readings. I mean, that's literally what shows up on the right. So if I slow this down, 500 microamps, 15, 1K. If I slow this down to the point where it takes a little, oh my gosh, it's not going to take long enough. Okay, well, 100. Okay, let me slow it down even more. 200. 15. 1K. Oh my gosh, go slower. You know what? Hold on. 25. I'm curious. Let's try this. 200 microamps, resistor, 1K. We might see a knee here. So it should get up to 15, and then it should slow down. Nope, it's just cruising on through. Okay, anyway, here's a moving average window. This is what I was trying to say. So, okay, not first, last, moving average of X readings. So, here's what I'm thinking versus, okay, let me just say, here's what I'm thinking, okay? So, only problem is you're limiting the current. Yes. I absolutely must limit the current. It's not possible to do this without limiting the current. Is that going to make this impossible? Classic formula only works if you don't. Well, and it's a different formula. Okay. I feel like there's a way of doing this. Maybe real world makes this impossible. The printouts here are not representative of an RC circuit. So for those of you who may have an idea of what's going on but don't fully understand it, let me explain the broader picture here, and doing this might actually just help me get my brain wrapped around this. So for capacitor reforming, you need to limit the amount of current going into the capacitor. So it must always be bottlenecked. You can't let the capacitor draw as much power as it possibly could. If you do that, and the dielectric barrier of the capacitor has weaknesses from decomposing, from just sitting and existing without a voltage applied to it, the capacitor could potentially draw so much power so quickly that it blasts through the dielectric and then shorts and then, you know, boom, explodes. Or the capacitor could consume so much power to reform the dielectric by breaking it, reforms the dielectric by breaking down the electrolyte and consuming it to build an oxide layer to form the dielectric. It could do that so fast that it gets hot, that it builds up pressure, and then it could rupture, okay? So there's two failure modes for a capacitor during reforming, and we need to avoid both of those, and we can do that by just limiting the current. So when you configure my software that I wrote here, there's a current maximum. So what happens is, let's say we're at a steady state with the capacitor, okay? I raise the maximum amount of current that the capacitor is allowed to draw. Then the software does math. The voltage level is raised to a point where going through the current limiting resistor, that maximum current is what the capacitor will be able to draw. As the capacitor charges up to the voltage rating, the current that it will pull drops because it's going through the current limiting resistor. So the current charge rate for the capacitor for reforming the dielectric barrier starts to drop. When it gets to the minimum is when the circuit or the software says, right, we've been dwelling at this long enough. That is possibly the leakage current for this capacitor. So we're safe going ahead and stepping it up again. If it never reaches 150 microamps, then the capacitor is bad. The leakage current is insane. It's just never going to work correctly again. So we're at this point where we're limiting the amount of current because we don't want to blow up the capacitor, and then the current charge rate goes down. So we're never at a steady charge rate. The closest we could get is setting the current maximum and the current minimum to be very close so that it's constantly just waving up between those. That would be fine. There wouldn't be any problem with that. There's no real, the only, well, okay, I should say this. The only problem with doing that is that you either need a very conservative current minimum where you, or it's not a good thing to do. It just isn't. Because the problem is the leakage current for this capacitor, as an example, this one here we've been working with, volts might be, let's say 30 microamps, but the leakage current at 50 will be 500 microamps. We don't know. So we need to be able to adjust that value. And this is one of the problems that we have when we're doing this. Yeah. So can't we just measure it on discharge? No. We can't. After it's the only way to no. We have to measure it on the initial charge. That's the problem. Left side of window is not missing, it's just chat. For me. That's where I'm reading chat. Oh, wait, you're saying that this... Okay, yeah, fair enough. Actually, you're correct. There you go. Yeah, we can't measure it on the discharge. So, playful. The balance between the current maximum and the current minimum will tell us well, man, I guess there's an inherent trade-off between number of T measurements and resolution accuracy of the T measurements. I mean, yeah, this is a complicated problem. So playful, I could do multiple charges, okay? But I don't need to. If I do more, it's kind of just like, you know, I'm not really thinking too hard about it. I just want to be sure, okay? The method that I'm using here should be reliable through one charge. Because as it gets up to the high voltage, it's either rebuilt the dielectric or not. So, one charge and it's already reformed. Yes. The gap is intentional. Okay. We know how much we put in. We know how much should come out. I mean... Oh, that's really complicated. We're looking for the lost energy. Huh. Okay, back. Hello. That was weird. Um, okay. Yeah, sorry about that. Okay. Um, all right. Okay. So, all right. Anyway, you're saying, yeah, measure the watts put into the cap. It's really difficult to say. So we could take an average, maybe, of the. We need to calculate milliamp hours, essentially. Or amp hours. Is our big software installation that ended up being downloaded twice, ate a bunch of bandwidth? Um, Maybe. Actually, you might be onto something there. Let's do like 10 steps, use the classic formula. 5RC. I don't know. I think I'm gonna have to think about this more. I think I need to read how you calculate this stuff a little more, become better informed with it, and then try and figure out how I could apply it to what I'm doing. Yeah, that's what I was thinking. We could do it within each step before. That's why I was saying per step. The other thing we could do, we could have effectively a third plot line that is the have a million steps to accuracy. Well, so I don't normally have a million steps. I mean, it's going to be like 30 to 50 steps probably. I mean, it's going to be a lot of steps. Um, I mean, it might be like 100. I don't know. Bigger steps mean higher current inrush, which is not good. So we can't have more big steps. That's the problem. And by the way, yeah, for the internet that just went out, I had to restart the Raspberry Pi. I don't know why that fixed it. Maybe the Pi's not working great. Yeah, Adam, that's kind of what I feel like right now, is that the thinking is the thing that needs to happen more for this. Hmm. It's working right now. That's what really matters. Also, we validated the math. Yeah. The easiest be to plot the ideal slope. Yeah. So add pi cooling. I mean, it technically has that, but I don't think that's the issue. I'll get numbers you can see, but the cap is good or not visually. Yeah. So what would that look like? So fun thing, we can just replay a log. Whoop. Here's fake data. Yay. That one doesn't seem very long. Hold on. Play it, everyone. Replay. Okay. So we have the micro slopes. Those would only be useful over here, I think. Why did it restart? Yeah, I think those would only help over here. Don't worry about the left side. I'm only talking about this right now. So, because here's the thing, you can see this part here, how tiny these are. We can't really see the steps there. This is what's important. Uh, V in Y, time in X. Yes. Graph voltage is Y, time. I guess I can just scroll down here. Okay. So we could calculate it potentially each time here. Or would it be better off here? Think about the formula for a bit? Yeah. We only have 19 minutes here, so if you're on Discord, it might make more sense to talk more about it there. The nice thing is, hold on. You might be able to just run this. Logs. Okay, so this 3 microamp log, you could run this. So you could run this log. It's in the GitHub repository if you wanted to see that, and you could apply this logic to it. I'm not going to go on Discord if you want. All right. Well, yeah, I'm just saying if you come up with something, because I'm not gonna be live again until Friday. So if something pops up, it might be best to just talk about it there. But we have this is the amount of current going into the capacitor, so it ramps up and then ramps down. It might make sense to, I don't know which of these two graphs it would make more sense to put it on. I'm also not sure why it went so far below the I min. I wonder if my setup is wrong. Anyway, there's something here worth looking at later. We got the cap reforming. Can you just look at the time each step takes and draw the conclusion from there? Kind of. That's basically what we're thinking, but the problem is the classic formula, this, assumes 0 voltage to target voltage. But it's a non-linear slope. So if you start at a known or like a mid voltage and then you change it, it also changes. Additionally, I think this assumes like infinite current is available, and it's not. I don't know. This is difficult. The main graph, it's easier. But on the main graph, so the main graph becomes useless over time. That's why I'm not putting that one on the OBS overlay. It's like, for example, here's why I don't like the main graph. The V time graph, that is the main graph. Here, let me give a demonstration for everyone. Okay, so we're going to set our target voltage to 25 volts, okay? We have a 100 volt capacitor connected right now. We can do whatever we want. My current maximum is usually 2 milliamps. What if I make it 0.2 amps, okay? 200 milliamps. Let's see how fast this reforms. Closest attempt to convey the idea on TT Live? Okay. So the steps are going to be enormous. Or the capacitor is disconnected. Well, that's interesting. Smaller graph, which is zoomed in, part of the main graph. There's also V time. So there's 2 small graphs. Once this gets enough samples here, I mean, oh, geez. This graph is the same as this graph, but it is only this many data points back in the history. This graph is current versus time, but only this many sample points back. It's meant to give a zoomed in view of the last this many point samples of this graph. Yeah. I don't know why this is not working. Hold on. 15. Wait, did it just fail on the other one? That's weird. All right, so 3, 4, 6, 7 steps. To 100, not 1,000. I don't even know, man. One step. That's what setting the max current rating does. It massively changes the step sizes. All right, let me look at this. What Wizard Tim sent. Actually, I can do it on here because for once I actually have this on. Okay. Time 9.6 hours. Okay, top is during reform, bottom is reform. Difference is RC time concatenates success. Yes, Wizard Tim. So basically what you are saying, if we go back to the second to last log, let's replay that. All right. So what you're saying is the time value changing to here, okay? So again, I don't know why it runs twice. Points are stays at that value. Yeah, but okay. I think we're saying the same thing. We could do a calculation for how long it should take to do that step. Do we for calculating that for each step? That, as far as I understand it, because this is assuming calculating the whole thing. Yeah, because the current limiting only work inside a step. Yeah, so I'm fine with that. So we would have our ideal amount of time that it would take, and then we could measure the time over that it takes in reality. All right? And then we can just sum up those total times. Sum up the total times per each step and then the times. And then we'll get our percentage off of it from there. And then we could run it again. And then we can see if there's a change in the percentage on the sum total of each step. So it requires 2 runs to validate that the capacitor is currently don't have a metric that, but this could give us the metric. We would still require 2 paths. It's going to happen. But that could do it. Like technically protective, like graphing off, yeah. But you can also do 1 run only. I could, and then figure out how bad it was, but is. Because if the is not great, then it will perform the same before. Like I have one cap around here that I have no idea where I'm hearing about this a little while. But I had a cap that had really bad, and it kind of simulated reforming a single time I ran it. So it was really great. But so you could multiple times, you'd always have that time difference. You can see a change in time difference reforming. So we do have to do it twice, no matter what, because we need to see that time delta between the expected and the change. That's what we need. man, I'm sorry about the, I don't know if that's going to be a precursor to stream dropping. I have no indication of when that happens. So my apologies. Also, it looks like my audio is still peaking. Okay, I think is the audio cutting out all the time, or does it come and go in waves? At least this only matters for 8 more minutes. Actually, you know what? I have an idea. I will be back in just a second. All right, I have reduced the audio bit rate to hopefully have it survive more. I don't know. But all right. Okay. Playful, I'm going to reiterate what I was saying when apparently the audio was bad. I think all the new studio transmitter link protocol doesn't work very well on. Well, the audio problem that kills the deck talk is unrelated. I don't know if that's what you're talking about. Anyway, we have to run the test twice on every capacitor because I have some capacitors that have bad ESR or bad leakage current that will always show a significant difference between how long it should take and how long it does take. So you have to run the test twice to see that that difference shrinks. So no matter what, we have to run it twice. But as long as we can do a cumulative total of how long it thinks each step should take and how long each step took, we should be able to get that value just by adding all of those up and then giving a percentage difference. We're not talking about the deck talk. I think you had to change container format. Oh, yeah, okay, that I did change, yes. Okay, but we can calculate how close it is for each step in real time. Yes. Yeah, we can do that. No, it doesn't work even if you do it in one run. That's I think the ideological difference. So in one run, we can tell how bad it was on that one run, but that doesn't tell us how much the capacitor has improved. So you can think of that run as how bad the capacitor was in its initial state. But then once we run it again, we see the results of the reform. So Wizard Tim, I'm not sure the last few steps should be far better than the first ones. No. So reforming is a chemical process that induces a physical result inside the capacitor. It is the increase in thickness of the dielectric. Every time we go up a step, we have new dielectric that we have to rebuild. So no matter what, as you increase or as the steps happen on the first pass, you physically have to wait for the dielectric to rebuild every single time you do a new step. The second time you run it, the dielectric is already rebuilt. That's what the difference is. So the second pass, it will not be pulling in current, converting it to heat, and building that dielectric. It'll just charge the capacitor and then lose whatever it gets to leakage current. So the two steps, the two passes will be different no matter what. As long as it reformed even just a little bit. Yeah, we can just do the global time. Yes, that's what I'm saying. So we can add those up and calculate that as we go along. So that's why I was saying we could have another one of these readouts that tells us, you know, this is the difference between the expected time and the real time. But yeah, alternate method, delta V. I'm looking at what Wizard Tim has posted in Discord right now. Delta V is the difference measured capacitor voltage and set cap voltage step. Blue is during reforming process. Red is a successfully reformed capacitor, less current, less voltage difference. Yes, that's what it would be like. So that is the expected result right there. But so playful, we could look at the difference in time. We could from one run to the other. But the thing is that in real time, if we calculate this, we could get a percentage off, okay, of if we use the RC time constant to calculate how long it should take to charge, then we get a percentage extra time that it took to charge. We could calculate that charge time difference for the entire reform process, then run it again, and then we can see the difference in just that percentage. Or put another way, you could watch that percentage change in real time. Well, it probably won't change that much in real time, but you could see the number in real time. Or I'm trying to think, let me take a step back, explain this in a different way. Let's say I'm reforming 5 different capacitors, okay? As I'm reforming them one at a time, I see that the first one is taking 20% longer than the expected. And I don't know the numbers offhand. I'm just making this up. Let's say it's taking 20% amount of time and it goes through the full reform, finish, do it a second time. Now it's down to 10% of the time. Okay, I can see that. Move on to the second capacitor. It's taking 22% longer than the calculated time. Reform it again. It goes 11%, you know, is of the expected time. Okay, so I have a baseline there. I get to the third cap and it's taking 50% longer than the expected time. Now we have an outlier, and I can see this in real time with the outlier, that it's taking considerably longer than you would think it would. And I can watch that happen, and then it'll reform, finish the process, and then go again. I bet it would take about 50 to 45% again the second time. So that would tell us there's a high amount of leakage current in that cap, and that it isn't as good. So that could be our value. That's our percentage of how bad the capacitor is. And we could see that in real time. That's what I'm saying. We could also look at that as a before and after, but we could see that in real time, more importantly. So you're not really current limiting. Classical sense, you're changing the voltage. So classic form would still work for the global time. No need to bother with steps. I feel like there's 3 people here talking about different things. Or who want different outcomes. I don't know. I think I'm going to have to go do some reading. Figure it out. Understood what I want? Okay. I would like the real-time data. That's the thing. Doing it on post doesn't really... It's not as here's the other thing, Playful. I don't know if you understand this. This can take hours to do these caps. Depending on how slowly you charge it, it can take a very long time. So getting that bam instant feedback can be extremely beneficial. Well, this was enlightening. I don't know that I'm going to make any changes currently because it's working. Don't want to mess with it too bad. expected good starting point, just be theoretical RC curve in the chart. So the problem with that, Ben, is so it would be effectively the blue line, all right, not the red line. Red line is control. So blue line, you would calculate the blue line, but as a green line, I guess, and it would basically be the blue line just shifted over slightly. So it'd be how close to that it is. Load time will also be more sensitive to the run settings, whereas the RC time constant would be directly comparable between capacitors and runs. Yes. You don't have a C parameter, do you? Yeah, no, there isn't. Yeah, so Lanesy, that I can be more aggressive with the capacitor reforming if we increase the minimum current limit. 150 microamp, that's like obscenely conservative. Like really, really, you're going overkill. 2 milliamps is probably a good minimum current, but I don't know. We'll probably experiment with that in the near future. Hmm. Yeah, we would need a capacitor input for sure. It's kind of funny that we don't need one for this right now. Never even really thought about that. The actual capacitance does not matter. All right, we should end this. I gotta go home. I gotta get some new stools for the office because the wobbly one, I'm over the wobbly one. I am replacing it. So yeah, this is just give you an idea. This is the stool I normally sit at. This is without weight. That's how bad it is. Oh yeah, playful. No, it won't be that difficult. Because every single capacitor that I would reform would be microfarads as well. So. Okay. I might even be able to end the stream right now. Need to glue the stool. I don't think glue's gonna work. The only thing that would fix this thing is getting some L brackets made out of metal and drilling them in there. So, did the deck talk miss a thing? I don't see anything on the Twitch API backend. So, use screws. I'm not a big fan of the concept of putting just giant ones in there. You don't need RC, just directly measure T in seconds. But we need to calculate what the ideal T would be, wouldn't it? Anyway, we'll talk more about it in Discord. All right, I do need to end. This is funky math stuff. What am I missing here? Oh, I need to open No Machine. That's it. All right. Was sure on my end and took the bits. Man, I'll show you. There it is. There. Only 3 hours ago. Wait, how? 2 minutes ago. What on earth happened there? That's weird. Well, Ben, thank you for the 100 bits. I don't know why that didn't trip. I think, oh, I know why it didn't trip. Because the internet really went down for a minute there, and I think the script for connecting to the server may have died. All right. Oh, well. We got to end this. So, all right, outro. All right, well, thank you all for being here. We had some fun with Spectrum Analyzer. We got the capacitor reforming working on the new computer that we're using for streaming. Validated that it was all working. I'm pretty happy with this. So this is fully functional again for everything that I need it to do right now. And we've learned a couple of things there, like I need to return the 6-foot BNC cables that I bought. Those were garbage. So that's fun. But yeah, this was a beneficial day that I'm really glad that we did. Yeah. Oh, I forgot to mention, I found my EMI tape so I can make audio filters. Or, well, I mean, it's probably only going to be ever audio, but I can make RF filters and then shield them. Meant to mention that like 4 hours ago, but forgot. All right, if you all enjoyed this stream, you may want to follow to be notified when I go live again next. If you want to help support the channel, you can find me on Patreon or get a shirt like this one. It's a fake Model M. But that's going to be it for now, and I will see you all next time.